The message was encrypted using a shared secret, but it looks like one side of the exchange leaked something. Can you piece together this secret and get the flag? Download the message and source code. Looks like we have a Diffie-Hellman key exchange. So it looks like we have GPAB and the encrypted. Let's go to the message. Let's try and see if we can decrypt this. Let's try and XOR brute force this. There we go. So the notes from this challenge, what we did, we identified the vulnerability. The challenge linked the client's secret exponent B in a text file, message.txt, which is the core secret of a Diffie-Hellman exchange. Calculated the key. We used modular exponentiation, power ABP, to find the shared secret and took the last byte to get the XOR key. We converted the hex encoded encryption string into bytes and XOR'd each byte with our calculated key to reveal the flag. So that's the optimal way of doing it. But since it was only 256 bits, 1 byte, we were able to brute force. We used an XOR brute force approach to find which key produced a string starting with picoctf. Why it worked? Security relies on secrets staying secret. By leaking B, the hardness of the math problem was bypassed. Weak key derivation. The script produced a massive 1048-bit shared secret down to a single 8-bit byte. This made the search space small enough to brute force in milliseconds. If the key space is too large, brute force is impossible. You then need to check for leaks, look for other leak parameters like we found here. Ensure the prime P isn't small or doesn't have properties that make the discrete logarithm problem easy to solve. Implementation errors, looking for flaws in how the shared secret is converted into actual encryption key. Mathematics, revisit the fundamentals. So I'll probably do a theory video on, I'll definitely do a theory video on Diffie-Hellman and example on how to solve them. And just as well, XOR stands for exclusive OR, is a bitwise operation used to combine a plain text with a key to produce ciphertext. It is the cornerstone of symmetric encryption because it is computationally fast and carries a unique mathematical property. It is its own inverse. The XOR operation compares 2 bits and returns 1 if the bits are different and 0 if they are the same. Why it's used in crypto? The most important feature for your challenge was reversibility. If you XOR a message with a key, you get ciphertext. If you XOR that ciphertext with the same key again, you get the original message back. Let's move on to the next challenge. Password profiler, general skills. We intercepted a suspicious file from a system, but instead of the password itself, it only contains its SHA-1 hash. Using OSINT techniques, you are provided with personal details about the target. Your task is to leverage this information to generate a custom password list and recover the original password by matching its hash. Download the following files. Just having a look at checkpassword.py. Now we're just going to have a look at userinfo.txt. And let's have a look at the hash. Leet mode is a system of modified spelling used primarily on the internet that replaces standard letters with numbers or special characters that look similar. So hyperspeed print will actually visibly show all of the potential names that it comes up with. It looks cool, but in terms of speed and efficiency, encryption hash, password.txt, perfect. Now if we run this, there we go. That was a great challenge. I had a lot of fun with that challenge. So the first thing I want to cover is the key concepts. So SHA-1 hashing is a one-way cryptographic function that turns text into a fixed length string. You cannot reverse it. You must guess the input and see if the hash matches. OSINT is open source intelligence, gathering publicly available information, names, birthdays, families, to narrow down the possible passwords. Targeted brute force. Instead of trying every random character, use a profiler to create a dictionary or likely combinations based on the target's life. The workflow, step by step. So phase 1 is information gathering, pretty simple. Phase 2 was generating the ammunition, CUPP, which stands for Common User Passwords Profiler, to generate a custom word list. Interactive mode, we ran via Python 3 cupp.py-i. Phase 3, the challenge provided a script check _password.py. We tested against it, and pretty much it loaded the password once a match was found. So it was a pretty straightforward, but I really enjoyed this challenge because although it was simple, it just showed a lot about how brute forcing can be done more effectively if you already have targeted information. It intercepted a suspiciously encoded message, but it's clearly hiding a flag. No encryption, just multiple layers of obfuscation. Can you peel back the layers and reveal the truth? So looking at the message, what is a classic sign of base 64 is that it's a long string of alphanumeric characters ending in an equal sign. What we're looking at here is probably hexadecimal base 16, and how we can identify it is that it only contains numbers 0 to 9 and letters lowercase a to f. And then there we go. So essentially, these are the notes that I've written up for this challenge. The key concept was encoding versus encryption. Encoding, also known as obfuscation, is a public method of transforming data into a different format like base 64 or hex. Anyone with a map can decode it without a password. Encryption is a method of securing data using a secret key. Even if you know the algorithm like AES, you cannot read the data without the specific key. The peeling process. We treated this challenge like an onion, removing one standard layer at a time to reach the core. A string of mixed case letters and numbers ending in a padding. An equal sign is a padding. So that's what signified at base 64. Hexadecimal is a string consisting of only numbers 0 to 9 and letters lowercase a to f. What we did instead was URL encoding. So the presence of the percentage sign symbols followed by hex codes like 7b is what we know for the starting of this curly sign bracket. And ROT13 is the rotated alphabet by 13 places. A is N, C becomes P to reveal the readable text. Binary digits. Riddle Registry. Hi, intrepid investigator. You stumbled upon a peculiar PDF filled with what seems like nothing more than garbage nonsense, but beware, not everything as it is appears. Amidst the chaos lies a hidden treasure, an elusive flag waiting to be uncovered. Nice. Here we go. Yeah, thank you very much. I don't think I'm going to create any notes for that challenge. And I hope to see you again next week.